Next. Perfect. Thank you. Next, I'd like to introduce our penultimate speaker. It's Joshua Lopez-Binder, and he's going to present his sculptural biomimetic heat sinks. Joshua's degree has changed a lot. Are you still self-defined in mechanical art?
Just mechanical.
Just mechanical engineering. For a while, he was doing kinetic art, sort of a hybrid self-designed degree. For his project, Biomimetic Heat Sinks, Joshua developed a computational model to create branching structures similar to stony corals. Biomimetic heat sinks could potentially eliminate the need for cooling fans by providing much more effective passive cooling.
Yeah, so I'm Josh, and that was a pretty good introduction. So, why am I interested in this project? Well, basically, computers get really hot, and that's a problem because if they get too hot, they get inefficient, and they can also burn out. And here's some examples of people trying to deal with that problem with fans. So the main solution, or the most common solution, is a heatsink, which is basically this device that has a bunch of pins and has a lot of surface area so that air can flow over it and cool the CPU of the computer. So I was interested in heat sinks, but I was also thinking about corals because I took this class in biomimetic architecture, and I was reading about corals because they're beautiful and fascinating. And corals have this really interesting behavior where they form different shapes depending on the conditions that they're in. So depending on like the light levels and the nutrient conditions and the flow conditions, they'll form drastically different shapes. And then finally, I've been interested in 3D printing for a while because it's pretty awesome and it lets you make these fractal-like shapes. So the shape on the right is a model that I came up with, and then on the left is this example of a fractal. And fractals are just shapes that have similar structures on multiple scales. So basically, I combined these three ideas, interest in heat sinks and in corals and fractals that you can make with 3D printers, to make a simulation of coral growth. And so the simulation is pretty simple. Basically, there's a mesh, which is nodes and edges, and these particles moving in a random walk. And when the particles hit like a node of the mesh, it sort of grows outwards as if it's been fed. And then really long edges get subdivided and short edges get collapsed. And that's it. I just sort of ran that process for a long time, and I came out with these shapes. So on the upper left hand is like some shapes that were made from a hemispherical seed. On the right is a shape that was made from like a square plate. And then in the lower left is like a time history of a hemispherical seed. And then finally there's like a sort of showing how, the bottom right is like a bunch of shapes with different edge sizes. So this was sort of to show that the simulation can create like a wide range of forms depending on the conditions. So finally I took these shapes and I 3D printed them. And with the help of Rob and Carol Kamada, cast one of the shapes in aluminum. And aluminum is a really high thermally conductive material, and that was important for heat sinks because you need something that can draw heat away from the CPU. And that was basically it. Thanks, Golan. If you want to see more bloops, there's some on my website.
There's some over there.
And there's some on the table over there. Yeah, thanks.